So let's start. The last class we learned solve the algebraic equations where we saw different types of algebraic equation and how do we solve it. How do we basically simulate it in Matlab or get the solution in Matlab. Today we will see how do we solve trigonometric equations. The equations which basically involves trigonometric terms like sine, cos, tan, so and so forth. Those equations we call as the trigonometric equation. Here on the screen, I am showing you one equations as sine square x plus cos square x plus 1 is equal to 0, or basically sine square x plus cos square x is equal to 1. Plus is not the correct sign. So how do we solve this? So these equations we can solve in a similar fashion the way we solved using solve as the command. So I'm going to solve it using Matlab. So I'm writing as equation 1. So basically before that let me have since of x. So I define x as a symbolic, and then I define equation 1 as sine of x multiplied by sine of x plus cos of x multiplied by cos of x minus 1. So this is my equations, and then I can solve it using solver as my variable a. I got x is equal to 0. So this is the way I can solve any trigonometric that is of t minus square root of 3. So I can solve this also like by defining since of t. That's my variables, symbolic variables, and then I can write equation 2. 2 into cos of t. 2 into cos of t minus 3 into, sorry, square root of 3 is qrt of 3. This is my equations, and then I can now solve equation 2. Then I have a of variables. So I got this answers. So basically, I can solve even trigonometric equations in a one variable with the help of solve as a solve. Uh, let's say another way we can even convert a trigonometric equations into variables. So for example, if you have equation like 3 cos square theta minus sine theta plus 3 is equal to 0. So we know that cos square theta plus sine square theta is equal to 1. So if I substitute cos square theta is equal to 1 minus sine square theta, so I get these equations converted into the form. And if I say x is equal to sine theta, this equation gets transformed to this form. And by solve as a solver. So let's try this. So I have SYM since TR I can write as the 3 into cos of dt into cos of dt. That's a 3 cos square theta minus sine theta minus sine of dt minus sine of dt plus 3. This is my equations. Then RT is equal to, so then VE solve EQ4. So I got, and then VPA is equal to what I got is the theta value. Complicated. Complex conjugate forms. Or I can write EQ5 is equal to uh, this equation minus 3x squared, something like 0.8. X is already in symbolic form. So minus 3 into x squared plus minus x plus 6. This is my equations, and then I can have R is equal to, so will be solve of EQ5, then EQ8 hour. That's what I got. X is equal to, but x equal to, in my modification x is equal to sine of theta. So I need to find out inverse of this sines or a sine, and then I will get theta. In earlier equations, I can directly get theta. So this is the way I can solve algebraic equations. If we have more than one variables, then we can solve those type of equations using fsolve as the optimizing solver. See, when we have one equations, one variables, we are using solve. But when we are dealing with more than one equation or one variables, then what do we do in a general? We substitute the values or initial guess we guess the initial value of the variables and then try to do iterations, which basically give the answer when right hand side is equal to left hand side. So it's an iterative procedures. In one variable, it's not iterative procedures. In two variables or more than two variables and equations are coupled. When I say coupled means in equation 1 all the two variables appears, in equation 2 all the two variables appear. So those equations are coupled to each other. So until and unless I know the value of one variable, I cannot get the value of other variable. Correct. So if I have a coupled variable, coupled equations and more than one variables, I should go for optimization. So here optimization means basically I am guessing some values of these two variables and substituting into the equations. It will give me some value of another iteration's guess. So in this way I will proceed and a time will come when left hand sides of both the equation is equal to right hand sides, and that values of the variable which basically satisfies these equations is what is the value of that variables in that equation. So that has to be carried out using some optimization solvers. So here simplest optimization solver is epson. There is a lot of optimization solvers like cosmin, there is a fmin-con, there is a fmin non-con, so and so forth. So fmin constraint or fmin non-constraints. There are so many solvers available in MATLAB for optimization purpose. So here, what we did, we coded two equations in the command prompt itself, and then supplied b0 as the initial value for two variables. And then we wrote the epsilons as f, where we defined the equations, b0 as the inputs, and then options. And it gives us b in degree. So b in radian, and then we convert it into degree. Clear? So whenever there is a more than one equations, we can use epsilons or any optimization solvers. So, as I explained you, the simple algebraic equations, correct? There might a chance that in examinations, I might not provide you direct equations to be solved. I might provide you some scenarios from which you need to formulate the equations, and then you get the set of equation, and then you need to implement the methodology which we learned in algebraic equation solutions. So here is the classical examples. So here are two forces, F1 and F2, pushing down on the stress at angles of theta 1 and theta 2. So this is F1, which is pushing down on the stress, and this is F2 at angle theta 1 and angle theta 2. Is given as F1 is equal to 10,000 lb at a theta 1 is 75 degree, and F2 is 7,000 lb at theta 2 as 45 degree. Okay, so if this stress problem is given, then you need to resolve these stress problems and try to find out R1, R2, and R3. Correct? So here are the equations. That's R1 plus P1 cos of C plus P2 is equal to 0. Some forces from here, some forces from here, and then you need to resolve this at mode points and get these equations. So we get six equations, one, two, five, six, seven equations. We get almost 7, 8, 9, 10 equations. We get around 10 equations if you model the stress problems, and we have unknowns like R1, R2, R3. and then T1 to T7. So we have 10 unknowns, 10 equations. So it's almost a linear set of equations, linear algebraic set of equations. Correct? So we need to formulate the methodology. We know that how to solve it. So here is the matrix, which is formed in the A. This is A matrix. These are the B, and these are the C. Or sorry, AX X is equal to B. And if we solve this, we can take the inverse of A and find out R1, T1, T2, R2, T3, T4, T5, T6, R3, and T7. Another classical examples from our chemical engineering is this. It has a feed stream which has 10 unit of chlorates, which has weight percentage or weight fractions for component 1 as 0.2, component 2 as 0.6, and component 3 as 0.2. If it's flashed, then you get converted this streams into two streams. So stream F2 is X1. We really don't know the flow rate, but however, we know the mass fractions of this stream. And then the bottom side products again get flashed into the two streams, that is F4 and F5. We know the weight fractions of all these, but we really don't know the flow rates. Correct? So our job here is to find out X1, X2, and X3. So what I'm going to do, I'm going to wait here for almost 5 minutes. You people try to formulate the equations from this diagram and then try to find out X1, X2, and X3. And then I'm going to ask Hello. Okay. Who wanted to share the screen, man? Is anyone completed?
Yes, sir, I can share.
Yeah. I would wrote the modeling equations.
Not in that, like I just wrote the matrix and then solved it.
Yeah. Yeah. So it.
Should I?
Yeah.
Is it visible?
Yeah. What you did?
Here I wrote the A matrix.
A matrix.
Then B matrix did this, and I got the values of x1, x2, x3.
My A matrix is different, man. X1, X2, X3 is equal to 10. But you wrote is 0.04. So you took the fraction balance, huh?
Yes, sir.
Then your B matrix might be changing.
Yes, sir. It's that the first stream given with the fraction of 0.2, 0.6, and 0.2 of
Okay.
x.
So what's the answer you got?
The first stream, that is, I got this 5.82,
Second one is 2.43.
2.4, and third is 1.7433.
Okay. Okay. So this way we can solve the algebraic equations. So now at this point of time, I think I explain you the basic use of Matlab. Okay. From next lecture onward, we will start developing controllers. That's the last portions of this course. Okay. So let me get to know your situation in process control or PCI, which you call. So Pratish, what
Yes, sir.
sir is teaching right now in PCI?
So we are going through control valves and everything.
Sorry,
That is the portion. Control
what?
valves.
Control valve.
Yes, sir.
Does he explain you about the classical controllers, that is P, PI, PID?
Not yet, sir. Like that has to be done.
Not yet,
But
has to be done. Does he explain you about forcing function?
yes, sir.
So like step forcing functions.
Yes, sir. Yes, sir.
Okay. He might have explained you Laplace transform.
Yes, sir. Laplace is done. Transfer function is also done.
Okay. So in the next lectures, I am trying to explain you the classical controllers, and then we can start writing or designing the controllers. Basically, not designing. We can start controlling the small system. That's the last portion, and then we will start the presentations from you guys. Okay. So here I'm going to stop at this point of time today. I will meet tomorrow.
Hello, sir.
Yeah.
Sir, I had a doubt from ordinary differential equations.
Yes.
Sir, in case of ODE2,
In case of A,
ordinary differential equation of second order, we break down, we have a ODE of second order with an initial condition.
yes.
We further break it down into two. One will
Yes.
be equal to V and other would be the equation converted.
Yes.
Now I'm confused with to which equation what initial value should I give, because the original equation say it was at time t equal to 0, the value is 2. Now that 2 is to be given to which one, the equation 1 or 2?
Okay. Okay. So now what we do, let's try to understand the basic. Okay. So we have a dummy variable.
Yes,
Okay. Let's say that dummy variable is v.
yes, sir.
Okay. Now we assign that v equal to dx by dt.
Right.
Correct. So we write a
Yes,
dx by dt is equal to v.
right, sir.
Correct. Now another equation comes which have dx2 by dt term.
Yes,
So we substitute there instead of dx2 by dt square. Instead of that, we substitute dv by dt. So basically, we are differentiating the equation number 1.
right.
Correct. And we convert that equations. So while converting that equations, you will find out that the differential term is dv by dt.
Yes, sir.
You agree with this one?
Yes, sir. I totally agree.
The first equation is dx by dt.
Yes, and that is only we are utilizing for second equation.
But the second equation differential term is dx by dt.
Yes.
That's dv by dt.
Mhm.
Are you getting, or shall I explain
Yes, sir.
you?
I'm getting it.
No. Wait. Just a minute. I am going to put my.
Sir, I have sent an example on the group, so it's similar to what you're
No.
explaining.
So your problem with the basic concepts, Karthik, and I know many of you might have this problem. Just I'm just putting my right. So this my screen is visible, Karthik, correct?
Yes, sir.
Okay. Let's just a hypothetical example, okay? Uh, so so here d2x by dt square plus dx by dt plus x is equal to 0. This is the equation. Clear? Now what do
Yes.
you do? We say that dx by dt is equal to v. Correct? This is the assumptions. And we say that this is equation number 1. Then what we do? We convert these equations by substituting these dummy variables. Then we say that instead of, so if I differentiate these equations, differentiate equation 1, what I get, d2x by dt square is equal to dv by dt. This is what I get. I substitute this here. So this becomes dv by dt first term. Second term dx by dt is v. And third term x is equal to 0. This is my equation 2. Are you agree, Karthik?
Yes, sir.
Okay. Now you tell me, forget about these equations for a moment. Forget about these equations for a moment. If I solve these equations, the solution I am getting is for x or v.
For equation 1,
Yeah, if I solve equation 1 alone, Will I get the solution for X or solution for V?
For X we will get.
Yes. So the equation 1 provides us the solution of X. Correct?
Yes.
And equation 2 provides us the solution of
Towards V. Yes, sir.
Agree, because the state variable here is X and state variable here is V. Correct?
Yes. Yes, sir.
So I am getting, if I solve equation 1, I will get solution for X. If I solve equation 2, I am getting solution for V. Agree? These are coupled
Yes, sir.
equations. That's an altogether different story. Okay?
Hmm.
We cannot solve it separately, but for a moment I'm talking. Now, what the initial condition given with this equation to me? Let's say X of 0 is equal to 0. Where I will substitute this? Is this the initial conditions for this equations or this equations?
Sir,
If it,
equation 1.
it should be,
Equation 1.
and then I differentiate this dx at 0 by dt is equal to 0. Correct? And dx, I know that dx by dt is v. So v at 0 is equal to 0, which is the condition for this.
Oh, yes. Got it, sir.
Clear?
Yes, yes, sir.
Okay.
Thank
Is there
you.
any other questions?
No, sir.
Okay then, thanks.